Hello, everybody. Good afternoon. It's a pleasure being here. Thanks a lot for hosting us today. I wanted to quickly introduce myself. My name is, as you can see, Ayman Shukri. I'm actually a principal program manager lead in the Visual C++ team. I've been with Microsoft for the last 13, 14 years. I actually am driving the design parts and the program management and architecture parts of the compiler, Visual C++ compiler, linker, and libraries. So I've been there for quite some time. So if you want to know a little bit about the history of the team, I'll be more than happy to do that, but I'll probably keep the secrets hidden for now. So what we'll talk about today, I just wanted to stress something about Renaissance. And the Renaissance part, it's more about what's happening there in the market, about the growth and the change of the stress of C++ and what's driving that C++ renaissance. As well, we'll dig into some of the Dev 11, and here's Dev 11 is actually the internal code name that we used for Visual Studio 2012 before releasing. And we will choose some of the topics, pick and choose some of them, and we'll dig deeper there. And hopefully we get some time at the end to cover some of the important parts and answer some of your questions and concerns. So thanks in advance for kind of a more interactive session here. So Renaissance, it's an interesting English word. And parts of that, that's what it is on actually the dictionary says. It's a movement of period of vigorous artistic and intellectual activity. It's a rebirth or a revival. It's an area where basically there's an explosion of creativity, and the market is driving that right now. That means there are new innovators, like yourself and others and us and everybody. There are new projects that are coming up, and we're going to go through what does this mean exactly. And the interesting part here is that we, as well as everybody else, is starting to learn from each other. Teachers became students, and students become teachers at the same time. And that's what part of the renaissance that's happening there. And we'll talk about the next phase of what's driving that. So, driving specifically for the C++ renaissance, we see really four major parts here. And the number one is the new relevance of what we call cross-platform, right? And cross-platform in that sense is not really about the operating systems only, like not Windows, Linux, and Mac, and others, but more as well of the hardware cross-platform. Right? You want to write your app, you want to have it, the same app running, right? You want to have it on Windows, you want to have it on your PC, you want to have it in your tablets, you want to have it in your phone, and different kinds of phone. And that's where the whole market starts changing and Renaissance starts changing. Just ask a quick question. Who writes now apps for all those platforms? PC, phone, and tablet. Just raise your hands. Okay. Okay, so lots of hands in the back. So do you pick, and the next part is really our expectations from our customers, correct? Our customers and your customers at the same time. They expect applications or games that are close to reality. That means if I'm turning a page and I have a video of turning the page, I want it to look exactly like what we do in human life. I want it to look like right. It's just not a page that's turned. And that reality and physics engines and gestures, all of those are driving the innovations on the C++ side. The other part, of course, is the hardware evolution. Like we have companies like Samsung, Intel, AMD, ARM, all those bigger hardware companies. And what they're doing every day is there are new hardware innovations, whether they're sensors, GPUs, vectors. And what's asked from us developers is to really capitalize on that and utilize those kind of hardware investments. We'll talk more about how Visual Studio 2012 helps you take advantage of those kind of innovations. The last part that we'll tackle as well today is going to be more about how developers like ourselves are really greedy. We want to do everything of the first three, and we want to do it in less time. So we'll talk about how we can enable that through Visual Studio. In fact, the rest of the sessions as well today will cover lots of those aspects. But let me first, and I'll probably move a little bit, introduce the, about a myth that we used to have on the C++ side. It used to be believed that C++ developers are those old guys with beards. Right? It's like they're not the cool dudes, as Americans call. So they're not the ones that are doing the innovations, but more they've been in the market for a long time. We did a survey in Microsoft about the ages of people and C++ developers. And as you can see, the majority really is in that area, the bigger number, which is the range from 24 to 36 years old. This is the range where C++ developers, so it's no longer, and that's part of the renaissance that's been driven. It's no longer the old folks or old guys in the past or girls that's actually doing C++. In fact, if you're in the US, there are folks that look this way, correct? Just any picture I've had. Did anyone notice something here in this chart? Shout it. Shout hi if you notice something strange here or weird. Nobody, I'm sure everyone noticed, but they don't want to say. Yeah, I see some people pointing at the top. Yes, it's that guy. Interesting. He has 92 years old and doing C++. I just hope he's not waiting for the build to get done. But the only powerful part that comes to my mind is that guy. That's the only thing that comes to my mind, right? That can do this kind of stuff. But yeah, it's interesting that there's a 92 years old that's still doing that, which is really interesting. The other myth was mainly that C++ projects are actually old projects, and it's only investments that we have, and we want to just invest a little bit. Again, the survey revealed that actually 50% of the projects written right now in C++ are 0 to 4 years old. So there are actually lots of new projects being written there in C and C++. And that's what's driving the renaissance as well in the market. There's more apps, more projects that want to take advantage of the performance, of the hardware, of the different cross-platforms of tablets and phones and PCs. And they're saying that C++ is the language to take advantage of those kind of innovations. So another statistics which sets back a little bit of the background, there's the types of new C++ projects that are being written. As you can see, the higher parts are in gaming parts, which is around 20%. The rest is engineering and frameworks. In fact, I would say gaming is the majority as well, because lots of the engineering and science frameworks are either researching for physics engines and stuff like this, which gets rolled into gaming, as well as frameworks or gaming frameworks as well, like Unity and Unreal and Reality and all this stuff. This all gets rolled into the C++, our gaming side of things. So I just want to look and see if that kind of percentage is as well here. Who's here working in gaming? Who's mainly in gaming? Just raise your hands. Okay. Who is in mainly engineering and science, like research and doing stuff? Frameworks and business? Okay, interesting, it's all over. How about imaging? Okay, the hard question now. What about the other? Okay, there's some people that never raised their hands, but I hope you enjoyed the talk though. So why do developers choose C++? As we said, there's number one reason is we want to be close to the hardware. We want to control our app or our game or our framework. We want to be able to get the real-to-life experiences there. And we believe C++ is the language that gives you that ability. The other part is the cross-platform. C++ is not a language that's owned by Microsoft. It's a language that has its standard body. And the standard dictates how the language looks like and what are the semantics behind it and syntax. So that means if you build something, if you write your application in C++, you can use Visual C++ compiler to compile for Windows. You can use GCC and others for other platforms, but you maintain same source code. So yeah, cross-platform in that sense. The other part is compatibility. And it's actually, you can divide it into further a couple of areas. The number one part is, as we've said, like the guy that was 92, he's probably been writing for like 30, 40 years C++ applications. So there's tons of existing source base of C++ that you need to keep and invest it. The other part is C++ is really the language that understands all other languages. Meaning, if you have a C# and then you have a Java part, and you want to communicate together, the way you do it is through building a shim layer of C and C++ or accessing through a C++ API. Right? So it becomes the translator or the language in the middle between the different technologies. And that's where that area becomes very important as well for C and C++. So, the part about cross-platform that I wanted to tackle about is talk a little bit about the history of it. So, the old pattern was, I want to write one application, but I want to run it on all platforms. Right? Unfortunately, you end up by an application, mediocre application, which means you're not really capitalizing on the platform-specific options or light-ups in the different platforms. You tend to have okay apps, but they don't stand out on certain platforms because you want to just target all at the same time. So the new trend of more of a newer trend there, correct? Every platform is coming and saying, well, for iPhone, I want to use Objective-C, correct? For Java or Android. And now we'll talk about more C++ CX, which is component extensions that for more of Windows 8 store apps. And there's, of course, HTML5 and JavaScript for your web applications. So basically, right now, the best experience is to use the platform programming model itself that the platform is suggesting. In Windows 8, we're going to talk more about C++ CX. In fact, my colleague, Ulzi, the next session, he's going to dig deeper in how to use C++ CX and build apps there, direct apps with it. And the thing that I want to announce as well, or re-announce for some folks that we announced it before in Redmond, and I want to re-announce it now for those who don't know. Windows Phone 8, which is coming this year, will support C++ development. So you'll be able to have C++ apps on Windows Phone 8. Right now, in Windows Phone 7 and 7.5, only managed code was supported, which is C# and VB. But in the next version, C++ is a first-class citizen there. So, for the next 2-3 slides, I'll speak specifically about Windows 8 parts, but then we're going to open it to different operating systems as well. Who here has used Windows 8 or tried it or have seen it? Hands if you've seen it. Okay, a big number have seen it. So hopefully you'll try it soon. I have it on my machine now. Windows 8 is an interesting operating system, not only in the way it was designed, but in the way it was even run inside the company. It was, for the first time, we align Visual Studio release with the platform release, with Windows 8 release. And believe me, these are, you're speaking about teams that are thousands in number of people working on that. And to align both teams together and release in one day and finish the code and declare, hey, we're done at the same day, what can I call it? It was actually a nightmare. It's just a nightmare to get that done at time. It was long nights and days, but it was done. But we've learned a lot from it, and hopefully we'll do it more often. Well, we'll see how this goes. So what this means is Windows 8 itself, when being brought up, have taken into consideration by design-wise what is the story for developers on that platform. In fact, this is just the architecture of Windows 8, the developer architecture. You have still the old way of desktop apps here, which basically C# and VB using .NET, C++ and C using Win32 APIs, and then HTML and JavaScript for the Internet Explorer parts. I mean, we're all aware of those areas. We've been doing that for a long time. The other part is we introduced the Windows Store style apps, and we'll see demos of those today. And these are partially, think about Windows as the runtime for your application. Meaning, I don't have to worry about deploying my runtime. I just put my stuff there, it works. So the Windows parts, it's still all here, all right? This is Win Runtime APIs. The OS takes into advantage and gives you the benefits of all the graphics, the device printing, all of those functionality. You can just hook your apps to those functionality, but what we call contracts with your application, with the operating system. And as well, Ulzi will have some special demos for these areas that I would like definitely encourage you to look at. The other part is all those Win Runtime APIs are actually accessible by all C++ languages or Microsoft languages. And the new part that we're announcing today, it's more of a XAML support for C and C++, which wasn't there. It was only for C# and VB. Who have heard about XAML? Raise your hands if you have heard about XAML. Okay, there's quite a few hands here. So I think that's good news for you. XAML used to be only for C# and VB. So definitely it's now in C and C++, and I'll show you as well the demos for it. Yeah. And of course, DirectX as well is actually a tool that's supported there. So what does it mean to have C++ in the Windows Store world? That means three things. First one, that you can actually write, as we said, XAML C++ applications, where XAML is your user interface, and C++ code is your back end behind that and your engine. DirectX based as well for your UI and games. Lots of people using DirectX, raise your hands. Okay, big numbers at the back. And then the other one is what we call hybrid applications, which is basically HTML5 and JavaScript for the front end, calling C++ runtime APIs for the operating system. Basically, that's more of the web apps itself. I would like to talk a little bit about, and a touch on it only, because Uzi is going to go deeper in the next session, but C++ CX, which stands for component extensions. The idea here, it is a set of languages and libraries to allow you to directly consume the new Windows runtime on Windows 8. So it applies only for Windows 8, but for taking advantage of the Windows 8 runtime parts. The idea here is that you don't have to learn a new language. It's STL-like. It's automatically reference counted, and it's deeply integrated in Visual Studio from the debugger and profiler and all those aspects. So you basically decrease the barrier for entry there. So hopefully it's going to be easy for everybody. I'm just going to show you a quick demo of what does this look like. And I want you to start counting now the startup time of Visual Studio. Like, count for me how many seconds. I want you to count in loud voices if you can. With me. 1, 2, started already. So I hope that's something that you're interested in compared to previous releases. In previous releases, you used to go start your application and actually go get some coffee or go to the bathroom or something and come back till it starts, right? But hopefully that's covered now. And that's the part of it is we're compiling with the new compiler here. So as you can see here, this is a very quick application of using STL, standard vector. And you can use the new string type, string hat. That's purely native. That's not managed C++. It's just native C++. And that's the type of a string for the Windows runtime. And you can just mix it with existing C++ code and it just understands it. Okay? And what I did basically, you're just pushing on the stack 1, 2, 3, 4. And I create a new platform, and that's the platform parts collection. And I just iterate through that collection and then sort it by calling the STL sort as well. So I did not create any new applications or new libraries. I'm still using what I'm used to use, STL. All right? And when I run that, just to make sure, so as you can see, it's being printed first 1, 2, 3, 4, and then 4, 1, 3, 2, which is alphabetically putting the numbers. All right? And the way it is to close apps in Windows 8, you just tackle them from here, put them down. So the other part that I wanted to tackle on is as well how you actually get your app close to reality. Right? And that's partly about how did we enable DirectX debugging, models, writing designers, and all of that graphics parts. And we'll talk, I'll show you just a few snapshots of this. So right now in VS, you can manipulate 32-bit images in VS, the panes. We support all the modern new image formats for that. The other part is for your games, we have the models that you can build. You can build transformations, basic shapers. You can control your cameras for the game. That's all embedded in Visual Studio 2012. My favorite parts here are the visual designers for DX. So basically, you design stuff there visually, and you say, please export to my HLSL, the high-level shader language. And here you go, you have your code, you've designed it, you have your code as well for it, automatically done. And you can just compile it, and we have it hooked into the DX compiler there. Another interesting feature here is enhancing the graphics debugger. One of my favorite parts is the event history debugging as well, which means I can replay some of the, like say you have a bug, I can replay the events of that bug, replay the scenario, and debug exactly what was happening, correct? That's the scenario event, the call stack for it, that's all stored so that you can actually reproduce the issue and start debugging it line by line there. And that's part of how to take advantages of the new capabilities there. Okay, C++ and the hardware. I'm going to read you this because that used to be the mission for Microsoft from 1975 to 2005. Put a computer on every desk, in every home, in every pocket. Correct? That was the kind of the mission statement where all are driven in that area. And then the free lunch is over. All right? It's like, well, every hardware now comes with multiprocessors. And how can we take advantage of that? And that was still early 2011, where it's like, great, we're going to write tools that help people take advantage of multiprocessors, get automatic speed up if we can. Who knows the third one now, which I personally and others call it, welcome to the jungle, correct? It's just everything. Put everywhere, everywhere. It's like you have tablets, supercomputers, phones, all kinds of hardware. And you know what? As you as a C++ developer are expected to write apps for all this hardware stuff. Seems unfair, but that's our business, I guess. It's unfair business. So what did we do in Visual Studio 2012 to make that happen? There's a different parts that I want to touch on. Partially loop vectorization. It is the kind of compile and smile optimization I'd like to call. It's basically, you don't have to do any changes in your code, and you just recompile your application and it becomes faster. The reason is most of our machines right now has vector registers, correct? And we suddenly, not suddenly, now in VS 2012, by default, are making use of those vector registers. So we can do multiple additions, multiple operations at the same time using those registers. So, for example, if you had this piece of code, this loop, what the next step this is going to happen is when you compile it in VS 2012, the loop is going to, the compiler is going to look at this and decide, well, it looks like it's just an addition. You don't have dependency between the different iterations. So we'll convert it to something like this. Basically, it did 4 additions at a time using the vector registers. So in that sample, you suddenly have 75% of performance gain for that loop because you just use the XMM registers straight ahead. And you don't have to do any changes. The compiler does that for you right now. And I'll show you a video, actually, of how this is done. So basically, that used to be the case. Now we make use of the vector registers in the hardware parts. The other part is here. How many of you is aware of or PPL, Parallel Patterns Library? It used to be in VS 2010. Let me ask a different question. How many people is using VS 2010? Raise your hands. Okay, VS 2005, which is older. Okay, VS 2008. Okay, VS 2012 already. There's 2 there. There's 2 there. Okay, so hopefully there'll be more next year. So for loop vectorizations and PPL, what we did, PPL is basically a library that's built in what we call concurrency runtime that we have, which makes you take advantage of the multi-core systems. Basically, it's something that you say, instead of have 4, whatever loop, parallel.4, which means please do these iterations on the different platforms. And we've actually modified those areas, and we've made it more of the algorithm, more parallel algorithm there for you to help in that library. The next part is, who heard about C++ AMP? Accelerated Massive Parallelism and GPUs. Hands, if you heard about it? Okay. So, who have done GPUs in general, GPU programming? Okay, there's only Uzi raising his hand at the back. So part of that is how to take advantage of GPUs. And the idea here for AMP is just C++ code. You just use C++, so tell the compiler, please move this part on the GPU and handle the stuff for me. So you get performance in that area, and I'll show you videos as well. And from a productivity, you don't have to learn new languages. You don't have to learn CUDA or OpenCL. And the other part that's actually important is portability. You don't have to worry about what kind of GPU card you have here. Right? It's basically based on DirectX, so it's supported for NVIDIA, it's supported for ATI cards from AMD and others. As well, we've worked with other companies like NVIDIA and others to put that as an open specification of C++ AMP, so that other compilers can build C++ AMP applications as well. Let me actually display a couple of videos here. The first one is more about the compile and smile parts, which basically is going to show you a bouncing ball app that actually compiled using VS 2010 And then the same app exactly, the behavior of it without any code changes, how it behaves differently in 2012.
Hello, my name is Eric Broomer, and I'm a developer on the C++ Compiler Optimizer team. I'm going to demonstrate the power of the auto-vectorizer and auto-parallelizer improvements we've made in Visual Studio 2012. This is a computationally intensive ray tracing application that simulates rays of light bouncing off of objects to produce a realistic-looking image. It's written in portable, parallel C++ code using the Visual Studio 2010 compiler. To enhance realism, we're going to add a Gaussian blur to the resulting ray traced image. As you can see, this drags the frame rate down significantly. It runs around 1.5 frames per second. The blur filter is representative of heavy workloads that read, write, and compute quantities of data. Things like image processing or audio processing algorithms, mathematical operations also fit the bill. As you can see in the task manager, we're not able to achieve broad CPU utilization on this workload. In other words, the ball isn't bouncing very fast. Here's the same application with the blur already enabled, compiled with Visual Studio 2012. First thing you'll notice is the ball is bouncing faster. It's achieving around 16 frames per second, and as you can see in the task manager, we're using all 40 cores to their maximum, yielding around a 10x performance boost. By vectorizing and parallelizing the key loops in the blur filter, we're able to use all the available horsepower on this 40-core machine. All 40 vector units are being used to do the ray tracer computation.
So as you can see, it's basically just recompiling this application, correct? Led to 10x speedup, and on automatic scaling to whatever number of processors you have. So you don't have to do anything, like you don't have to control exactly how many processors or not. Even if the operating system is blocking some of the processors for different, still the scheduler takes care of that. In fact, this is the piece of code that's actually very heavy that gets auto-vectorized. You don't change it, but it just gets faster just because of the auto-vectorization there. And I'll show you now another video that's more about the AMP and how strong it is for having a GPU access.
Hi, my name is Daniel Moth, and today I will show you a very quick demo of one of our C++ AMP samples that we call NBody. You can get the Visual Studio project and all the code for the sample by visiting our blog, and I will share a link to that at the end of this short video. So in this app, what you can do is you can change the number of bodies. So currently I'm at 4,000. And you can also switch between different implementations of how we perform the calculation of simulating the gravitational interaction between that number of bodies. So currently we're using a single core implementation. So we're simulating how these red dots basically interact with each other, and that's an expensive operation. So you can see that right now with 4,000 bodies, I'm getting 18 frames per second, and I'm getting just over 6 gigaflops. If I was to go and throw more bodies at this, so if I just double the number of bodies that we have, you'll see that the gigaflops actually doesn't go up. That means that we have maxed out the compute capability that we can get out of this single core, out of this hardware. And of course, because we have done that, when we threw more bodies, the frames per second went down because it's taking longer to go and render the frames after it performs a calculation of where each body should be in that next frame. So what I can do is I can also go and use a multi-core implementation. So we coded up a different code path using PPL, the Parallel Patterns library. And if I choose that, you'll see that now the gigaflops and indeed the frames per second go up. So we get a nice increase in the gigaflops that we're getting out of all these cores, and the frames per second has also jumped up compared to the previous state. And if we go and open the task manager, we'll see here that we're using 100% of the 4 logical cores that I have, and the graph demonstrates that. If I was to switch to the single core version again, not only things slow down, but you can see now the utilization has significantly dropped. And And the real number here is just under 15 because a lot of the CPU utilization is taken up by the recording software that I'm using to produce this video for you. And actually, that's a good point. I want my CPU to be used by other tasks, not by my truly compute-intensive algorithms such as the one that I'm running here. And that's where using C++ AMP comes in, and you see the CPU utilization drop into just what the recording software uses, while the gigaflops have jumped up considerably. It's now 260, so we're way over 10 times faster than the multi-core implementation with the same number of bodies. And of course, I can go and throw even more bodies at it. So if I just go and double again,
So as you can see in that part, we went from a single proc to many core and then to GPU. So we took the whole thing of capitalizing on all the hardware parts. And I think that's the promise of VS 2012, to take advantage of that kind of hardware revolution. Right now, I'm just going to probably run faster than expected for some of the parts. We'll talk about C++ 11. And it's the promise of more productivity by following the standards. I'll leave you to read this. VS 2010 versus 2012. You can see lots of the no's got now to the yeses side of things. So hopefully I will continue investment in that area to track the C++ standard. The other parts I'd like to point out in VS 2012, the backward compatibility of the project system. You don't have to do the upgrade project system parts. No, VS 2012 understands the project system format for previous Visual Studio versions. The other part as well is sophisticated multi-monitor support. So if you have multi-monitors, and like most of us do now, so you actually have full support that in the IDE right now. Again, more of the IntelliSense, and Uzi will show more in his demo when he's doing the IntelliSense stuff and the C++ CX. But it became more aggressive in IntelliSense and more of the modern code editor capabilities there. ALM, I think ALM is one of the parts that we invested heavily in C++. We have fully supported unit testing now for C++. Like some of my favorite stuff in project management and others are the sprint planning and task boards, which is a more of operational side of things. I guess what's next on our side? First of all, we continue the Renaissance. We want to continue the investment. The reason we're here as well is to hear from you, as we are in a great time right now to get feedback between the different product cycles. It's the right time now to get your features and your suggestions, your pain points, so that we can tackle that in the next releases. And we're going to the model of what we call VS updates, which basically you don't have to wait till the next Visual Studio. No, we're going to do it quarterly, every 3-month updates for Visual Studio to get some of the asks into the product. I encourage you to look at a project called Casablanca. It's a project that we released on Dev Labs. It's more about now the next phase of taking our code and parts into the cloud itself and your applications. And please do check our blog. We announce all our new stuff there. And for us to get good reviews, we're required to participate there. So you will get good answers, hopefully, from there.